Okay, so the first thing that I want to do today is make sure we know how to graph individual points. So the first thing we're going to look at is graphing all of these points that were given here. So our first point is 3, 5. Now, do you remember if the x or the y comes first in an ordered pair? The x. So it would be x, comma, y. Now, is my x-axis my up and down axis or my side-to-side axis? Side to side, so this is x, this is y. So when it asks me to graph point M, I'm going to go 3 on the x-axis. So since 3 is positive, I'm going to the right 3, and then I also have to go up 5. So this would be point M. Then if we graphed N, since 2 is negative, this time on the x-axis we're going to go to the left 2, but then our 4 is positive, so we're going up 4. Okay, now if we're looking at P, our x is 0, so do we go right or left? Okay, we don't go either. We only go up, so we're going to go up 5. This would be then for F, if my x is negative, which way am I going? Left. So I'm going to go left 1, 2, 3, 4, 5. And am I going up or down since 1 is negative? Down. So that would be F. Now, our last point is G. So it says negative 4, so which way am I going first? Left. 1, 2, 3, 4. And then do I go up or down? Neither, because it's 0. So it would stay right here on the x-axis, and this would be G. So are we good on graphing points? Okay. The next thing that I want to look at is finding x and y intercepts. Okay, do y'all remember what intercept means? Very good. Where it crosses or where it intersects the x and the y-axis. So y'all told me that the x-axis goes side to side, the y goes up and down. So at what number does it cross the x-axis? 1, 2, 3, 4. So my x-intercept, is going to equal negative 4, 0. So you write it x and y. So at negative 4 at this point, did we go up or down at all? No. So the y is 0. So let's see if you can figure out the y. So the y intersects here. So write out what you think the y-intercept would be. Okay, who thinks they know what it is? Mackenzie, what do you think? Negative 3, what? Very good. Since we didn't move right or left, that means our x is 0 and our y is negative 3. Do not forget our ordered pair is x, comma, y. So for our y-intercept, the x will always be 0, and for our x-intercept, the y will always be 0. Okay, and number 3, let's look at our x-intercept. Bryant, what do you think our x-intercept would be here? So 4, comma, did I go down 1? Or did I just go to the right 4? Nope. If I went down 1, it'd be right here. I only went to the right 4 and put my dot because that's where it intersects. So it's 4, 0. the x and y intercepts will always have a 0 in it. So if you're looking at the x-intercept, the y is always going to be 0. Now for the y, Courtney, how would you write where this intersects? 0, -1. Very good. Okay. Now, I want to practice actually drawing our x and y intercepts. So let's look at number 5. If I wanted to draw my x-intercept here, since it's 4, I would go to 4 on the x-axis. So I'm going to go to the right, 1, 2, 3, 4, and put a dot. Then for the y-intercept, that's got to intersect the y-axis. So I'm going to go either up or down. Do I go up or down since it's a positive 1? You go up 1. Okay? And then we would draw a line through those two. It's kind of hard to line up without a ruler. Will you get Courtney one, please? Okay, let's try number 2. So in number 2, where am I graphing my x-intercept? Am I going right or left? Left. And I'm going to go left 3 times and put a dot. Then for my y-intercept, am I going up or down? Down. We're going to go down 2. And then we're going to draw our line through the 2. Okay? Is everybody good with that? Okay. Now I would like you to flip to the back of this page. Okay? We want to talk about evaluating quadratic functions. Okay? So when you evaluate, all you're going to do is plug in whatever value they give you for your x. So in number 1, they give me that my function is 3x squared, where f of x, or x, is 4. So I'm going to take this function, and every time I see an x, I'm plugging in 4. So I get 3 times 4 squared. And you can actually type this thing straight into your calculator, just like that. 3 times 4 squared. I know that 4 squared is 16. And 3 times 16 is what? 48. So my answer here would be 48. Okay, let's try another one of those. So let's look at number 3. So in number 3, we have 2x squared plus 4, where x should be 5. So every time I see an x, I'm going to plug in my 5. So 2 times 5 squared plus 4. Okay. You can plug that straight into your calculator. What do you get when you plug it straight into your calculator? 54. Okay, let's look at 5. Okay, so in 5, every time I see an x, I'm going to plug in -4. Now, every time I've plugged in that number, what have I put around the number? A parentheses. So that means even here, I got to plug in, when I plug in, I put parentheses, so it's going to be parentheses -4 squared minus 3 parentheses -4. Now, if you write it like that, you also have to type it like that. So when you put it in your calculator, you have to make sure it has parentheses. Okay? So I'm going to do it by hand. You do it in your calculator, and let's see if we get the same thing. What did you get? 28. Okay, good. All right. Let's try one more of those. So let's look at 9. In 9, we have a negative number again. So every time I plug in, I want to make sure I put my parentheses. So it would be negative 3 squared minus 7 times negative 3 plus 4. So you guys put that in your calculator. I'm going to do it by hand, and we'll see if we get the same. Is that what you guys got? 34? Okay, that's what you should have got. And if you're not plugging it in, you may struggle when it comes to the test. You want to make sure that you're doing this as I'm doing it so that you make sure you know how to plug it in. Okay? Now, we have done kind of this with our quadratic equations test. Not quadratic, the factoring quadratic equations test. This time, instead of doing the whole quadratic formula like we did, we're only going to do negative b over 2a. But we should remember how to find a, b, and c. So what would my a be here? 3. What is my b? Negative 12. And my c is 2. Make sure you always keep the sign in front. So here we don't have a sign in front of 3, so that means it's positive. Here we have a minus, so that means it's negative. And here we have a plus, so that means it's positive. So if I plug in here, that's going to give me negative b. If b is already negative, what happens to it? It changes to positive. So we get 12 over 2 times 3. So 2 times 3 is? And what is 12 divided by 6? 2. Very good. Okay, let's try one more of those. So let's look at 13. So in 13, what is my A? 4. What is my B? Negative 24. And what is my C? Negative 3. So we're going to plug in negative B is positive 24 over 2 times A. What is A? 4. So that's going to give me 24 over 8. What is 24 over 8? 3. Very good. Okay, so now let's look at the analyzing quadratic graphs notes. Okay, so we've been factoring quadratics. That's what our last test is on. Now we're looking at the actual graphs of them. So what letter does this remind you of? A U. Okay, these should be very straight. Okay, so this is actually called a parabola. So it tells you up there a quadratic function is a parabola. A parabola is always going to make the U shape. I want to make sure that it looks like a U and not a V, because a V is actually an absolute value graph, and so there's a difference. So every time, make sure it has this loop. Okay? Now, let's talk about the pieces of a graph. A vertex of a graph is its highest or lowest point. Okay? And the vertex has a maximum or a minimum. So, if it goes up, you're going to have a minimum, because our vertex here would be this point, because this is the lowest this graph goes, right? So that's going to be the minimum value that it can be. However, it continues going up forever. The thing about parabolas is they never stop. So it actually keeps going on forever and ever and ever up. Okay? If it goes down, that means it has a maximum. So here is our vertex. Here is the highest point it's going to be, and it's going to be going down forever and ever. Does that make sense? Okay? So, our vertex. We're going to find the point of our vertex. So, in number 1, if we're looking for our vertex, it's this point right here. How would I find the point for that? The coordinates. Does anybody know? We don't know? Okay, so I need to figure out how far from the origin of the graph it is. So I know to get there I'm going to have to go right 1, 2, 3, and then I'm going to go up or down to get to it. Down, 1, 2, 3, 4. So my vertex lands on 3, negative 4. So all I'm doing is counting from the origin, right or left, up and down till I get to that point. Is that fairly simple? Okay. Now, if it's going up forever, does that mean it has a maximum or it has a minimum? A minimum. Okay. Is it going up or down? Up. Okay, and then the end behavior. All the end behavior is talking about is the ends of this. Is it going up or down? Because these are the ends. So the way you would write it is up, up, because both of my sides are going up and up. Okay. Let's look at number 2. So to find my vertex, am I going right or left first? Right. I'm going right. 1, 2, 3, 4, 5. And then do I go up or down? Up. So I went right 5 and up 1. So how would I write that in an ordered pair? 5, 1. Very good. Okay. Does this vertex have a max or a minimum value? A minimum value. Hope, does it go up or down? Up. Okay, and Courtney, what would its end behavior be here? It'd be up, up, right? Okay, Tyler, in number 3, can you tell me what you would do to get to the vertex of this parabola? You would what?
0, 4.
So I would go up 4, but I don't have to go right or left. So you said that's 0. So we only went up 4. So that's 0, 4. Haley, does it have a max or a minimum there? Does it have a highest point or a lowest point? Okay, has a max. Khalil, does it go up or down? Does the graph go up or down? It goes down. Okay, and what's the end behavior, Mackenzie? It's what? The end behavior. It's either going up or it's going down. And it's going down. Okay? If you are not paying attention, that is not an excuse for not answering a question. Okay, let's talk about the axis of symmetry, or the AOS. So, symmetry, does anybody know what that means? Okay. It means symmetry is where you could split something in half and it would be the same on either side. So our axis of symmetry is where you could split this in half and then fold it over and it would be the same. So right here, this would be our axis of symmetry, because if we cut that in half and flipped it over, it would be the same. Okay? Something that is really neat about the axis of symmetry is that it always passes through the vertex. Okay? And it's a vertical line. So that means every time we do our axis of symmetry, it's going to be x equals the number. And it's actually the number of whatever x is in your vertex. So let's look at this vertex. Brianna, can you tell me how I would get to this vertex point? Where would I go from the origin? I would go which way? I would go up how many? Up 1, 2, and I would have to go to the left 1, 2, 3, right? Is y'all's different than mine? Oh, it doesn't matter which way you count first, but yes, your x is going to go before your y. So if she said we went up 2 and then we went left 3. So you said our x goes first, so that's right and left. So what should my vertex be written right like? -3, 2. You're literally just counting your lines to that point. Okay, so if my axis of symmetry always goes through the vertex, what is x going to equal here? -3. Very good. Okay. Haiti, can you tell me how you would get to this vertex here? You went to the right 2 and up 3. So how would I write that as an ordered pair? 2, 3. And so our axis of symmetry always goes through the vertex. So Bryant, what would our axis of symmetry look like? Or how would you write that? X equals 2, because that's our x value, right? Okay. Let's look at another one of these. Carnisha, tell me how you would get to this vertex here. You go right 1, 2, 3, 4. And down 2. Okay? So how would I write that as an ordered pair? 4, -2. Very good. And our axis of symmetry always goes through the vertex. So Dasheen, what would x equal here? 4. Okay? Okay, so now we're on the back looking at domain and range. What you need to know about domain and range. Domain is always my x value. And then, what? And then range is going to be my y. What Khalil just said is that domain is always going to be all real numbers. And so the notation for that looks like this. It's a fancy R with two stripes. Okay? If you can't remember how to do it, you can put ARN, all real numbers. Okay? But you're going to have to know what this is, because you're going to see it on the ACT, you're going to see it on standardized test, you're going to see it when you go to upper level math. Okay? Okay, so if it goes up, you have a minimum, so your range is going to be y is greater than whatever your lowest value is. So if it's going down and you have a max, what do you think it would be? Y is less than. And it's actually, it should be less than or equal to, and this one should be greater than or equal to. Okay, so let's look at a few of these. Jalen, tell me how you would get to this vertex. You would go over 1, 2, 3, 4. You don't count the one you start with. We start here and it goes 1, 2, 3, 4. So see how I'm on track with that? And then we go down 1, 2, 3, 4. Okay, so if we went left 4, what does that mean our x is? -4. And we went down 4, so our y is -4. Now, does this have a lowest point or does it have a highest point? A lowest point. So is that a minimum or a maximum? A minimum. Okay, because this is the lowest it goes and it goes up forever. What would our domain be? All real numbers. Okay, and so our range, you told me it has a lowest point, so every y value is going to do what as the sides go up? The y value is going to get what? Is it going to get bigger or smaller? As it goes up, it gets bigger. Okay, so that means our y has to be greater than or equal to its lowest y value. What was its lowest y value? -4. Okay, let's look at another one like that. Here is my vertex. Can you tell me how you would get to this vertex? Okay, I'm going over 4. Am I going right or left? Left. And so what would that make x then? If I go left 4? Would make it negative. Okay? And then do we go up or down at all? Nope. So that means our y value is 0. Haiti, does this have a minimum or a maximum? A minimum. Okay. What is my domain? All real numbers. Okay. And so is y going to be bigger than -4 or smaller than -4? Sorry, than 0, because we're looking at the y value. Does it go up from 0 or does it go down from 0? It goes up, so y is going to have to be greater than or equal to 0. Okay. Khalil, I want you to tell me, how do I get to this vertex right here? How would I have to move? Up, down, right, left? Where am I going? Where? So from here, I'm going down to get there? Which way am I going? Up. How many up do I have to go? Five. We start here and we go 1, 2, 3, 4, 5, and then am I going right or left? How many? 1, 2, 3. Okay? Which goes first, right or left or up and down? Right or left. So that means if we went left, is it positive or negative? Negative. So it would be negative 3, and then we went up 5. Is that what I said? Yes. Okay. Does this have a maximum or a minimum? A max. Okay, because it's got a highest point and it's going down forever. Its domain is going to be all real numbers. And then its range, am I going down from 5 or am I going up from 5? Down. So y is going to have to be less than or equal to 5.